Welcome to my series of creating a RTAB SLAM bot from scratch. In this video, we'll be looking at the basics of SLAM and basics of RTAB, and along with the software and hardware components required for the implementation. So starting with the basics of SLAM. SLAM is short for simultaneous localization and mapping. This is basically a technology that allows robots to build a map of the environment while simultaneously determining their position within the map. So usually sensors like camera, IMU and LiDAR are used. The SLAM algorithm takes in the sensor data and creates the map of the environment while also simultaneously determining its position in the map. So I will be using an example to explain this. Let's say tomorrow you wake up and you are stranded in an island. You find yourself stranded in an island, and the first thing you want to do is know where you are and also what's around you. In simpler terms, you want to create a map of the island. So let's say you start here and this is the starting point. You start here and you go a few meters right or straight and you find a big boulder here, big boulder or a big rock, and from this you keep this boulder as a marking point or as like a mark location marking, and from this boulder you go right a few meters. Here you find one big weird tree and keep this as the second marking, and from this tree you go a few meters right again where you find a small pond which you will be using as another marking. So on this course of the path you find a few markings and use that marking so that you can return back to your original point. And this markings not only help you find the original point, it also helps you determine your own location related to the original point. So you end up here. Let's say this is the end point. Now you know where you are relative to the starting point. So this is basically how SLAM works. For a robot, how this works is it starts in a starting point and then it goes around the map and maps the environment using LiDAR or camera, where the IMU is inertial measurement unit. IMU or the encoder data is used for the odometry part. Usually a combination of IMU and encoder is used. So this is basically the SLAM working in simpler terms. Now we will look at RTAB. So let's start with basics of RTAB or RTAB. RTAB is short for real-time appearance-based mapping. So this is a software algorithm or software tool that helps us to create a 3D map of the environment. It uses sensor inputs like depth camera and IMU and encoder along with LiDAR. LiDAR can either be 2D or 3D, and encoder is usually the rotary encoder. So how RTAB works is it has visual features extraction tools which extracts visual features from the camera and uses that for loop closure detection. So what loop closure detection basically is, it helps the robot to recognize previously visited locations. So I will explain that with an example. So using the previous example, let's say this is the starting point and the robot starts here, and on the way it finds few objects, and these data will be recorded in the robot, recorded by the robot. And when the robot goes this path and returns along this way, it will notice the same features that have been recorded previously. So it will match these features with the previous recorded features, and notice that it has already visited this point or location. So that's what loop closure basically is. And uh, the other thing RTAB does is it also helps in the graph optimization. Graph optimization is done in order to make the map globally correct, and also to make sure that there are not much drift in the map. Drift happens when there are errors in sensor data, and along with the camera movement. The camera movement is also responsible for the drift in map. So these are few image examples of the RTAB working. So if you look at here, this is an example of the RTAB map. The blue dotted path is the path that is taken by the map, the path that is taken by the bot while mapping the environment, and the pointy structures that you see is the 3D map of the environment that was created by the bot. And these can be other examples, other maps. So you can actually simulate these RTAB SLAM bots. There are a lot of GitHub repositories that are available. You can also use Turtlebot for the RTAB simulation. Coming to the hardware and software components required for implementation. So this is a list of components that I would be using. The first one is Raspberry Pi. I have a 8 GB Raspberry Pi along with the Raspbian OS installed in it already. We won't be using the Ubuntu OS and Raspberry Pi because of certain reasons that would be revealed later in the video. And the next component would be Arduino Mega. I'm using Mega specifically because the IMU code that I've created for the IMU data processing is pretty big, and doesn't have enough storage for it. And the next we will be using Arduino Uno for controlling the motor drivers, and 12-volt gear motors for the robot's movement. You can choose any gear motors as per your wish. It doesn't have to be exactly 12 volt, or it's your wish. And the motor driver I will be using is this one. It's just for reference, I'm showing it. And coming to the IMU I have now is this BNO085 model. And for the depth camera, I will be using this AddoCam TOF camera. It provides both the depth data along with the RGB data. And for the encoder part, I will be using this rotary encoder. And the LiPo battery, you guys can select as per your requirement based on the motor and the motor driver. And coming to the software, pretty much all the code will be all the code and the simulation part will be done in the Ubuntu 22.04 OS. And mainly we will be using ROS2 Humble in Ubuntu 22.04, and also the RTAB of the native ROS2. The RTAB and other repositories are available. You can clone. I will show you how to clone those in the later videos. So that's all for this video. I will see you guys again in next video.